Okay, guys, we're going to continue learning about matter today. So our essential questions: what are the three states of matter, and how can we describe matter, as in the properties of matter? So let's get started. Alright, the first thing we're going to do is watch a video. It's called Hunting for Properties.
Hey guys, remember what it was like in preschool? If you don't remember, here's a reminder. It was way easier. Playing with colored blocks, learning shapes, those were the days. Good times. But here's a fun fact. When you were learning how to put all those yellow blocks in a line or stuffing square-shaped blocks through a square hole, you were also learning something very fundamental, and that is how to judge an object's properties. But what do we mean when we talk about the properties of stuff? Well, let's start with this. The stuff that makes up everything is called matter. Doesn't make any difference if it's a tiny grain of sand or all of the air that surrounds the Earth. Everything is made of matter. And a property of matter is just any characteristic that we can list about it, like how it looks, feels, or acts. For example, my characteristics include having black hair, wearing glasses, having some wicked awesome nerd cred, and, well, you get the idea. Properties of matter are also things that we can observe. This means that they have differences that are big enough to notice. For instance, I'm currently observing that my desk is messier than it was 5 seconds ago. And to round it out, properties of matter are also able to be measured. That is, we can compare objects to each other. But instead of just looking at them and getting a general idea of how they compare, we measure them by using tools that give us values or numbers. Now, let's put all of these ideas to work by demonstrating how we can find a few basic properties of a simple object. Let me grab my measuring tape. Okay, look. I know I was just talking about how fun it was to play with blocks, but let me be clear. I am not playing with these blocks. This is science, people. Now, let's start with a couple of questions. 1. What properties does this block have? Well, there are some properties that we can observe, but we can't really measure or describe them with numbers, like this block's color, or what it's made of, or even the fact that it holds its shape, which makes it a solid. So, a better question to ask might be, what can we observe and measure about this block? Let's start with the big one here, length. Length is just the distance of something from end to end, and this block's length is 8.5 centimeters. Width, meanwhile, is the distance of something from side to side, and its width is 8.5 centimeters. Height. That's an easy one. It's the distance of an object from its bottom to its top, not to mention a major factor in being able to play basketball successfully. And the height of this block is 9 centimeters. So length, width, and height are some of the most commonly used properties, but there are a lot of others too. For instance, our block is also an object shaped like a box that takes up space. That is, it fills up the space it's in. We call that space the block's volume. We can measure the volume of this block using math based on the measurements that I just made. But we can also get a more general idea of its volume by making other observations. Like the medium block easily fits into the bigger block, so we know that the medium block has less volume than the bigger block. But there's no way the medium block is fitting into the little block, so we know that the medium block has more volume than this small block. Finally, weight is another measurable property of matter. Weight just tells us how heavy an object is. When you go to a doctor's office and they ask you to stand on a scale, they're using that scale to measure your weight. Got it? Good. So, all matter has properties, and properties are observable, measurable characteristics that we can use to tell them apart. And we got to know some of the most common and useful properties that we can put a value or number on, like length, width, height, volume, and weight. So, hey, blocks. Not just for little kids, also super handy for doing science.
Okay, so let's talk about properties. Properties can be observed. That means you can see these with your senses. You can use your senses of sight, like to observe the color, size, or shape of an object. Look at the girl. She is observing the leaf. She can look at the leaf and tell the color, the size, or the shape of the object. Texture is another property. Texture is how something feels. Remember we talked about the texture of the balls yesterday? An object may feel hard or soft. It may feel smooth, rough, or bumpy. All right, guys, look at this melon. How do you think this melon feels on the outside? Bumpy, that's right. What about the tomatoes? They're smooth. What about the cucumbers, the carrots? They would be rough feeling, that's right, or bumpy. Even so, all of these different foods would have a different texture or feel to them. Texture is their property. That's something you can observe. You can feel it with your senses of touch. Now look at the shapes, colors, and textures of these objects. What patterns in nature can you see in this picture? All right, what do you notice? The fruits and vegetables are what? They're colorful, right? Are all of the foods the same shape? No, they're all different shapes. Some are round, some are oval. This is more of a cone shape. Right here are some round ones. Some are smooth, the texture is smooth. Some are bumpy. Some are rough. All right, so there are lots of different properties in these fruits and vegetables. And we could describe them all using their properties. Now, scientists use tools to measure accurately. That means the best way. You can measure temperature using a thermometer. Temperature is how hot or cold an object is. You can measure weight with a scale. Weight is how heavy an object is. All right, so we talked about weighing ourselves. Look at this man. What is he weighing? He's weighing the fruits. That's right, he's weighing a watermelon, and up here it looks like a peach. All right, so that is a scale that measures the weight of the fruits. All right, so if you talk about the weight of an object, you are giving an accurate description of it. All right, when you're able to come up with a number, just like with the girl measuring the boxes, it's a more accurate description of its properties. Your temperature, using a thermometer, gives an accurate description. Properties can be tested. Scientists often test objects for flexibility, hardness, absorbency, and buoyancy. They may also test if an object is magnetic. All right, they can test the hardness of an object. Hardness is a property that tells how solid or hard an object is compared to other objects. You can do a test to figure out the hardness. All right, you scratch. It's called a scratch test. And you use a nail or something like that to scratch it, and it decides how hard it is based on that. All right. It says minerals are classified by their degree of hardness, by whether or not they can scratch other objects. In third grade, you'll learn about Mohs hardness scale, and it talks about the hardest minerals to the softest on a scale of 1 to 10. All right, you can test an object to see if it is buoyant. All right, you can test if an object is buoyant by observing if it will sink or float. An object floats if it has gas inside of it or if it is lightweight and has a large surface. All right, so guys, will this ball sink or float? That's right, it will float. What if you throw a brick inside of there? It would sink, that's right, because it is heavy and not filled with air or gas. All right, so it would not be considered buoyant. All right, you can test if an object is magnetic. Some metals are magnetic. An object is magnetic if it can be pushed or pulled by a magnet. Alright, and so the way to test is to use a magnet. See if you can draw it to it or if it pushes away from it. Alright, you can test to see if an object is flexible. Some objects are flexible, while others are not. Matter that is able to bend has flexibility. You can test an object for flexibility by bending or stretching it. Alright, so look at the little boy. He's playing with Play-Doh. Guys, is Play-Doh flexible? Yes, it is. It is very flexible. You can move it and bend it without it breaking. What about a spoon or fork that you use from the kitchen? No, they are not. They're very hard, and if you try to bend them, they will not bend or break very easily. If you do try to bend them, they will break eventually. They will not bend around on their own and go back into place. So that is not flexible. All right, now let's review our 3 types of matter today. All right, it says states of matter: solid, liquid, and gas. You can type your name here when you get your copy. It says sorting, solid, liquid, and gas. Matter is everything that is around you. It is anything that has mass, that means weight, and takes up space. All right, just like ice, wind, apples, even tornadoes, steam, and orange juice. Matter can be either a solid, a liquid, or a gas. Some examples: solids like paper, acorns, trains, diamonds, and apples. It's things that keep their shape. Liquids: orange juice, water, pool water, oil. Here's another pool full of water. Tea, and the ocean. Gases like the wind, air like in the clouds, steam. All right, here you have some other type of vapor coming off of an experiment. All right, air you breathe, and helium, like to blow up balloons. A solid has a definite shape. That means the shape is not going to change. Shape has a definite shape, and its tiny particles are packed very tightly together. These particles cannot move. That's why it keeps its shape. All right, it says, place the group of solids in the box. All right, guys, is it group 1, Group 2 or Group 3, the solids. Group 1 is the solids. They have their own shape. So I'll move it into place. A liquid. A liquid takes the shape of its container, and its particles are packed loosely together. These particles can move just a bit. That's why liquid moves around. All right. We have water in this fish tank. It took the shape of that container of the fish tank, and orange juice in a glass. All right, so which shows liquids? Group 1, Group 2, or Group 3? Group 3 is the liquids. Gas. A gas has no definite shape, and its particles are spaced away from each other so that they can move about freely. All right, remember, a gas will take up all the space. All right, this would be like the air we breathe. Steam, when you boil water, is also a gas. All right, so which would be gas? Group 1, Group 2, or Group 3 pictures? Group 2, where you have wind, steam, you're breathing in air, and the clouds, the sky. Now it says, place 3 items into each of the solid, liquid, and gas columns below. Or you have water, steam, pizza, rock, ocean, oil, air, cloud, and blocks. You're going to drag and sort them. Remember, you have to be out of presentation mode, in this mode, to move them. All right, in the last page, it says circle yes or no to show if each object is in the correct table. So it says pizza. Is pizza solid? Yes or no? You'll drag it down and either circle yes or no on each one. Cloud. Is cloud a solid? Yes or no? Pencil. Is pencil a solid? Yes or no? Rock. Is rock a solid? Yes or no? All right, so you have enough rings to circle all of your questions. You have a liquids column and a gas column. Then you have definitions, solid, liquid, and gas. You'll drag the word to the box it belongs in. So it says this form of matter takes the shape of its container, and its particles are packed loosely together. These particles can move just a little bit. This form of matter has no definite shape, and its particles are spaced away from each other so that they can move about freely. And the last one says this form of matter has a definite shape, and its tiny particles are packed very tightly together. These particles cannot move. So you'll sort the words solid, liquid, and gas here. All right, fill in slides 11 and 12, and we will go over it on Monday. Do your best work.